Hey guys, so in this video I thought it would be cool to kind of make a video specific on welding cast iron with the torch. So this is something I heard about a while ago, and doesn't seem to be common at all, right? Probably because there are better ways to weld cast iron. But the thing is that you kind of need some specialty equipment. But what always interests me was to see if I can do it with a oxyacetylene torch, because an oxyacetylene torch is cheap compared to a TIG, and very convenient and portable and whatnot. So now in the past you've seen videos of me using this before, doing this before on some castings, and they turned out okay, but I've had limited success, and a lot of that I think is because of my technique, but because this is not easy. So today I thought it'd be cool to kind of work on a simple piece of cast iron, grind a little notch in it, and then weld it with these sticks. Now these sticks, I forget where did I get these from. I forget where I got these from. Some website out there. I'll try to find it and put the link down. But these are literally little rods of cast iron that they were cast in a little sand mold, and you can see the sand kind of texture on that. And you literally just melt this, and at the end of the day you have a weld that is made out of the same material as your base metal. Now the problem with this that I found is that it's hard to make it flow in. Now I don't know exactly, and if anybody knows, put in the comments. I don't know exactly what flux to use, so I started using just what I like, brazing flux, and that actually does seem to work pretty well. But it's still difficult because this is really thick, right? It's hard to kind of, it's not like a piece of like coat hanger wire or something like when you weld the steel. It's real easy to melt. You're just trucking along. This kind of like takes more finesse, and you kind of have to like preheat it as you're heating the base metal in the back and things like that. So today we're gonna run that bead down this piece of cast iron, and then I want to cut it in half and kind of look at the penetration and everything like that. And this is just kind of me messing around, but I'm bringing you guys along for the ride just because I think it's going to be interesting. Okay, so we got a piece of cast iron in here. It's pretty grimy looking, so we're gonna definitely clean that up. But we got it in the vise. It looked like I already did some practice for brazing right here. So the plan is we're gonna clean this up on the wire wheel, and then I'm just going to put a grind down the center like that, and then we're going to weld it up. Now this part is small, so it shouldn't be too hard to get it up to temp, so let's do it. So, gonna plug in our grinder here. I'm just gonna put a grind down the middle. It's hot, I don't want to touch it. Alright, we got a pretty big knots cut out right there, so let's weld it back up. Okay guys, I know it's dark, but I have the gas welding goggles on you, my other pair, so just bear with me here. I'm gonna turn on the torch, and what I'm going to do first is I'm just going to get the part nice and hot, You can kind of see it right there in the camera. I hope it's in focus. So we're going to just heat up the part, because the thing with cast iron, you got to make sure the whole part is hot to kind of control the expansion and contraction or cracking and whatnot. Plus, it helps to keep things hot, because, and what I mean by that is, as you're putting down the torch in a one specific small area, that heat isn't being sucked away as fast, because the rest of the part is hot. The rest of the part is hot, that heat kind of stays better in the spot you're welding at, and you get a deeper penetration. And if you don't get the penetration, then what you're doing really is you're really just laying the metal on top. You're not actually getting into the metal. But I think that should be hot enough. So now we're going to kind of focus on one area. Oh, actually before we do that, I'm going to just take my brush. I know it's hard to see. I'm just take my brush, and I'm just going to paint on some flux. So we're going to kind of heat up the metal as well as the stick. Again, because this is pretty thick, this stick. As I'm heating it, I'm kind of putting this close to the flame to preheat it. Okay, we're getting molten here. There we go. I'm going to keep trucking along. Making sure that we are melting the base metal before I dip into the puddle. Take these goggles off you. All right. So what you should do now is you should, I don't have anything set up to do this, but you should have some way to let this cool slowly. Put it in a thing of sand or something like that, or you know, a ceramic blanket or something along those lines, just so it cools very slowly. I had a little trouble towards the end making it look nice. It might be because we're close to the vise and the vise is sucking the heat out, and that's the thing. Welding like this, things have to be really hot. The part has to be hot enough. You have to be delivering the heat fast enough. Otherwise, what happens is everything just gets chilled immediately. You don't melt the base metal enough to really penetrate very deep, and you just don't have the heat. So we're gonna let this cool, and then I'll probably grind it down just so it's smooth. Maybe throw it in the lathe to have a smooth surface just to see what it looks like, and then we'll cut it in half. You know, it occurred to me I can grind it now while it's hot. I don't This is just a test piece. I don't really care if it doesn't cool quickly. So here we go. I think I will throw this in the lathe just to see what it looks like when I machine it. Okay, we're at the lathe. We're going to just take a skim cut off this now. Probably should be using high-speed steel, but that's right. Touch off here. Just going to go by hand, feeling it out. There are going to be high spots. That felt pretty good, so we're going to go in like 10,000. Do an auto feed. So let's see what this looks like. I want to get, this is the area we welded. You see it down there, there's kind of a bad spot, but that's okay. We're going to keep going. Okay, let's take a closer look. Come on, focus. Focus. So if you look here, it's kind of interesting. You can definitely see where the weld went in. And again, I know there are inclusions in there. But you can see that like down the middle here, there's a difference. Now ideally what I'd be able to do is break it so we can see the grain structure. What I'm going to do instead is I'm going to just cut it in half and we're going to just take a look and see what's going on. Alright guys, we're over here on one of the benches. So this is what it came out as. So basically what happened, let's see if I can get this, come on, focus. So you can see that right here, what happened was the edges melted easier than the bottom of that hole, of that crevice, because the crevice had more heat and sucked the heat away. So what happened was a lot of the weld has this void underneath it where it's kind of bridged across the top. And it's welded in there. You can see it's continuous. It's bridged across the top, but there is a void underneath because I didn't make sure that the base metal in the middle was melted. So you can look at this side as well. Same thing. And then I decided, well, what if I cut this in half? What does that look like? That's a little better. That's towards the edge of the shaft where it was easier to melt, but there's more welded in, but there's still a little hole. So that is operator error. That's operator error. But the edges look like it welded pretty good. So again, like I'm still practicing with this. It does look like a viable method, but it is definitely limited to, it's limited by how much heat you can dump into the part. Now ideally I'd put the whole part in a oven, heat the whole part up evenly till it's really hot, and then obviously spend more time spend more time to make sure that I actually melt the base metal at the bottom of the crevice instead of just sticking it on the side. So I think that's pretty much going to be it for this video. Again, I was just messing around trying to practice this kind of welding. I might try it again on video, but I think you guys have kind of seen what's up. I got to keep practicing because this is a good way to fix minor casting flaws in a casting, but it's difficult because, again, the heat problem. So let me know what you think in the comments about this, and I think that's going to be it for this video, guys. So thanks for watching, and I'll see you next time.